Today on How It's Made. Decorative moldings. We give this topic wall-to-wall coverage. Commercial pulleys, making the wheel that turns the belt in many machines. Industrial rubber hose, not your garden variety hose. And sheet vinyl flooring, the lowdown on this laydown. When you consider the high cost of renovations, architectural moldings are an easy way to get a lot of decorative bang for your buck. By adding a crown molding along the ceiling, baseboard molding, casings, maybe even a chair rail molding, you can take a room from drab to dazzling without breaking the bank. Decorative moldings can be made of solid wood, medium-density fiberboard, or finger-jointed pine. These planks of eastern white pine are on their way to becoming finger-jointed molding. They've just come out of the kiln dryer. A hygrometer measures the humidity in each plank to ensure the wood is dry enough to cut cleanly. A worker directs a laser to read the dimensions of each and every plank. The laser transmits that information to a computer, which guides a plane further up the line to shave the plank to the required width and square it. This process transforms the plank into a block. The blocks now enter a high-tech piece of equipment that identifies defects for removal. As each block enters the machine, a scanner records all its features. It sends that information to a computer, which calculates a cutting plan. Guided by the computer, a saw chops out any knots or poor quality wood. The machine's kickers, as they're called, boot the cutoffs from the conveyor. The blocks, meanwhile, continue on, running against razor-sharp rotating heads that carve finger joints on the ends. The next station coats the joints with industrial-strength carpenter's glue. The conveyor picks up speed now and butts the blocks together with high pressure. The joints lock in a tight fit. When the glue dries, the joints strengthen even more. The jointed blocks are connected in a continuous unit. A saw now cuts it into standard molding lengths. These lengths are known as finger-jointed blanks because they haven't yet been shaped. A saw now cuts the blanks lengthwise to the thickness of the specific molding they're producing. The final step is to profile the blanks. A machine called a molder uses rotating steel knives to carve the wood to the required shape. There's a different knife for each style of molding. The molder transforms the blanks to moldings at a rate of 30 meters per minute. Moldings made of finger-jointed pine or medium-density fiberboard are the least expensive to buy. But you can't stain them as you can moldings made of solid wood. You have to paint them. A pulley is a wheel with a grooved or barreled rim in which you run a rope or belt. It's a simple device used to lift a load that's hard to access or too heavy to move by hand. Pulleys and multiple pulley systems are vital components of many types of machines. These pulleys are designed for use in small to large-scale electric motors. For example, fan belts in the air circulation systems of office buildings, factories, and mines. The factory makes its pulleys from a 50-50 mix of scrap iron and steel. The furnace heats the metal to 1,370 degrees Celsius, slightly above the metal's melting point. Workers adjust the chemical composition by adding carbon and silicon. The right recipe is essential for producing quality metal. In the furnace, the metal's impurities, called slag, rise to the surface. Workers use giant paddles to skim it off. Once the lab analyzes and approves a sample, they transfer the molten metal by ladle to a 30-ton holding furnace. This furnace maintains the metal at a constant 1,370 degrees Celsius, the required temperature for a proper casting. You can't pour metal this hot into a metal mold